Hello! We are the Rio de Janeiro State University Rocket team, and we are here to present Mission Decennium, which consists of the launch of 2 rockets at the 7th edition of the Latin American Space Challenge.
Mission Decennium holds a special meaning for our team, as it's a name that celebrates our 10-year anniversary. Reaching this milestone is a source of great pride for all of us, and there is no better way to commemorate it than by doing what we love the most, launching rockets. Participating in LASC has been always a remarkable experience for our team, and being able to celebrate this moment in such a meaningful and prestigious competition makes it even more memorable. This video will focus on the Arceus rocket, ID 33, which competes in the 3-kilometer apogee category using solid propellant. The rocket is divided into 4 sections: propulsion, where the motor is housed; avionics, where the altimeters and telemetry system are located; recovery, which includes the drop parachute, main parachute, the tender descender and the ejection systems; and finally the nose cone, the aerodynamic tip of the rocket, which contains a dedicated compartment for a 2U CubeSat payload.
The composite material used for the fuselage, boat tail and nose cone is a combination of fiberglass and epoxy resin. Our fins are made of aluminum. The fuselage is manufactured through manual lamination with aluminum couplers securing the joints. The outer surface is then sanded and finished according to the final design. This year, we are going to be using an air brake system located at the boat tail section of the rocket. And don't worry, this right here is just a prototype. So, our propulsion system is based on a solid propellant composite made from sorbitol and potassium nitrate. Each grain segment is cast using a fiberglass inhibitor, which serves as a mold and a structural support during manufacturing. The motor is composed of 6 segments to ensure sufficient thrust to reach the target apogee.
Next, we present a schematic overview of each stage of a nominal Arceus flight. With a flight card in hand, the rocket is taken to the launch area designated by LASC and placed on the rail, where it awaits ignition authorization from event officials. After ignition, the propellant burn initiates the rocket ascent phase. Once the fuel is fully consumed, the rocket continues ascending due to its remaining momentum until its vertical velocity reaches 0, at which point it achieves apogee. At apogee, the altimeter detects the peak altitude and triggers the parachute ejection system. This system consists of a small black powder charge ignited by an E-match, which releases a pointed piston that punctures 2 small CO2 cylinders. The released gas pushes the nose cone away and deploys the drop parachute, connecting the 2 sections of the rocket mid-air. The drop parachute slows the descent to about 30 meters per second. When it reaches an altitude of 400 meters, the tender descender is triggered, releasing the main parachute. During the final descent, the main parachute ensures a controlled fall at approximately 8 meters per second until the landing. Once on the ground, during the recovery window, the designated recovery team contacts event officials and, using the coordinates provided by the onboard telemetry system, safely locates and retrieves the rocket. Thanks for watching,
and we see you on the 7th edition of LASC.